Welcome, this is Felipe Espinosa. I am a professor in the Engineering School, Electronics Department at University of Alcalá, Spain. The topic of this lecture is an introduction to sensing technology as part of the MOOC Building Robots, Sensor and Data Acquisition. This MOOC has been carried out by the Ruby team, partner from the University of Alcalá in the GEMS Erasmus Plus project. The schedule of this lecture includes the following sections. We will present the objectives. After that, we will introduce the main basic concepts about sensing as well as sensor classification with some examples. Next sections will deal with the main functional components of a sensor module and with their most well-known applications, valve monitoring and measuring signal for automatic control. Finally, we will review the main conclusions and list the bibliographic references and appendices. Starting with the objectives, this lecture is focused on the following aspects. Firstly, understanding the role of sensors to perceive the environment. Secondly, knowing the common functional parts and application of sensor modules. And thirdly, describing the main sensors included in the GEMS project prototype. However, we will not focus on physical or chemical nature of sensors, nor on aspects related to fabrication process of sensing elements. Following with the index of this lecture, we will talk about basic concepts and sensor classification. Let's first take a look at basic concepts of sensors. We will pay attention to the relevance of senses in human beings: taste, smell, vision, hearing, and touch. Do you remember the Blind Man's Bluff game? It is a clear example of the key role of the senses to perceive and interact with the environment, that means with the world. There is no doubt the senses are vital for human perception, cognition, and behavior. Now, we will try to explain why mechatronic engineering takes as reference living beings' behavior. It is well known that measurement of internal variables is necessary to self-regulate and maintain stability of vital human processes, such as balancing of temperature, calcium, blood pressure, sugar, etc. In the same way, sensors involved in biology processes are commonly analyzed and imitated by robotics and mechatronic engineering. Then, a sensor can be defined as a device that helps to detect any change in physical quantity. After observing the change, a sensor processes the detected signal and presents the result. A sensor should be sensitive to the main property it is measuring, but insensitive to other properties, like noise, in the same context. Moreover, a sensor should not influence the property it is measuring. There are different criteria to classify the sensors. Basically, we select the following. Sensors can be proprioceptive or stereoceptive. Proprioceptive is a sensor that measures variables internal to the system, for example, the engine temperature sensor in a vehicle. Stereoceptive is a sensor that measures variables external to the system, for example, the ultrasonic sensor for parking assistance in a vehicle. Sensors can be active or passive. We talk about active sensor when it emits energy and measures its response. For example, a vehicle radar, LiDAR, or sonar to detect obstacles along the trajectory. However, if the natural phenomenon is detected without any energy emission, we say that the sensor is passive. For example, the on-off seat belt detector in a vehicle. Finally, we can classify sensors between analog and digital. An analog sensor produces continuous time and continuous level signals. For example, the analog tachometer in some cars. But a digital sensor produces discrete time and discrete level signal. For example, the numerical speedometer in some cars. In robotic and mechatronic context, sensors are the key devices to perceive and interact with the environment in a natural and intuitive way. The figure shows different sensorial tasks implemented in a humanoid. Some of them emulate the human senses: vision, sound, touch, taste, and smell. Others allow to the robot wireless communication, speech capability, positioning, pressure detection, etc. There is a huge amount of sensor devices and modules available for mechatronic designers. The figures shows examples of commercial sensors. Some of them present single format, such as the phototransistor, LDR, and flex sensor, marked in red in the slide. But others are included in an electronic board, such as the ultrasound and color or vibration sensor, marked in green in the slide. Also in the James prototype, sensors play an important role. The Rubik car has been specifically designed to highlight the relevance of sensing in a mechatronic system. This electronic board implements a microphone device as sound sensor, and an ultrasonic car has distance sensor. Besides, the Diamond car, focused on control tasks, requires sensors to carry out its functionality. This is the case of the current and the motor axle speed sensors, based in Hall effect. A summary of the technical data of these devices obtained from the original datasheets are included in Appendix 1 and 2. Going on the lecture schedule, we will tackle the components of an electronic sensor module and the main applications. A sensor module includes two main functional blocks: signal acquisition and signal processing, both linked by an analog to digital converter. The figure shows the components of each block, allowing the sensed information to be presented and analyzed. Once the physical variable generates a physical stimulus, it is changed into electrical signal by the sensor transducer. Then, the raw analog electrical signal is conditioned to enhance its quality and accuracy. The signal conditioning mainly covers tasks such as filtering noise and amplification, but others can be necessary, such as linearization, multiplexing, etc. The result analog signal is digitalized by the converter. This way, the signal can be properly processed by the specific software application into a digital device such as a microcontroller. After that, the signal is ready to be monitored by the final user. At the top right side, we can see an example of how the voice of a speaker is captured. The small electronic board includes a microphone as transducer and the rest of the signal acquisition subsystem. At the bottom right side, we can see an example of electronic board where the previous one can be inserted. Then, the analog signal is converted, processed by a microcontroller, and monitored on a display. The general application of sensor modules are monitoring information and automatic control. Firstly, we will take a look at monitoring variables for the user. The figure shows an example of personal wearable sensor device. It offers variables of interest for runners: instantaneous and average speed, heart rate, tracked trajectory, etc. The right side figure shows how an infrared detector is used in maintenance tasks, such as detecting possible faults in an electric installation. In feedback control systems, the measured signals by sensors are compared with references to obtain the signal errors that will be compensated through a controller. This way, sensors play an important role in automatic control systems. This is the case of many sensors implemented in a vehicle: radar, infrared, camera, inertial, GPS, wheel pressure, etc. We are arriving to the last part of the lecture. time for conclusions, references, and appendices. Summing up the session, we review the main ideas about sensing. Sensors are to mechatronic as senses are to human body. They are the interface that allows us to perceive and interact with the environment. A sensor module integrates several electronic devices grouped into two main blocks, signal acquisition and signal processing. Transducer and digital processor are the more representative ones of each block. We can distinguish two types of sensor applications: information monitoring and signal feedback for automatic control. And finally, the mechatronic GEMS demonstrator includes a specific electronic board focused on sensing sound and distance, but other GEMS cards also require sensor devices. These are the recommended references. They have been used to prepare this lecture and are related to sensing concepts, theoretical aspects, and sensor applications. Appendix 1 shows a summary technical information obtained from the original datasheets of the microphone ABN713RC and the ultrasonic board HC-SR04. Both of them included in the Ruby card as part of the robotic platform carried out by the GEMS Erasmus Plus project. Appendix 2 shows the relevant technical information obtained from the original datasheets of the Hall effect current sensor TMCS1108 and the digital latch Hall effect speed sensor DRV5013, both of them included in the Diamond card as part of the same robotic platform. Hereby we conclude this lecture. Thank you for your attention. Enjoy the rest of the study.